My project began with a question about routine feeding of refined sugar to honeybees, a practice recommended by the British Beekeeping Association. For beekeepers, there's always a difficult decision to be made as to how much honey to take and how much to leave for the bees. Nobody knows what the future weather will be like and whether they will be able to make up the loss. If the beekeeper finds the hives are light, then sugar supplements are recommended, but mostly beekeepers feed preemptively, just in case they need it. And it struck me that this practice could be detrimental to bee health, as they may be lacking nutrition that would be provided by nectar, but not by sugar candy. There's growing concern that the honeybee diet is impoverished by current landscape use, and that their nutritional needs are not being met. This may in turn be having a detrimental impact on their health. Is it enough that there's a smorgasbord of floral sources available when required, or are there other elements specific to individual floral nectars that are passed on in the honey and are important to bee health? Do we need to know more about what effect a specific plant source may have? Although there is acknowledgement of antibacterial and antimicrobial properties in honeys, particularly Manuka and Calluna, much of the research has been in relation to human rather than bee health. Volatile oils and trace elements are small in quantity, but do contribute to the character of a particular plant's nectar, and therefore to its honey. Would there be a way to discover their effect, if any, on bee health? Ehler and Gehrman have shown how honeybees can use their stores as an in-hive pharmacy to self-medicate, choosing particular types of honey with antimicrobial properties when the colony was suffering from a gut parasite, nosema, that causes dysentery-like symptoms. Studying a plant with Goethean science can help reveal its relationship to the human being and health. So by focusing on the phenomena, the plant, one can hope to understand its essence and to be able to predict its therapeutic use. The bee and its relationship to forage plants is less well understood, however. So my question has become, is it possible to make a connection between the plant individuality and the well-being of bees? I chose 3 plants from the Ericaceae family to study. And later I introduced 2 plants from the Boraginaceae family to compare with the heathers. Dartmoor Prison. Miles from civilization, on bleak, windswept moors. The moorland home of heathers can be cold, wet and inhospitable. Heath and moorland are virtually synonymous with wildness. Emily Bronte's Wuthering Heights personifies the wild, untamed moors in her character Heathcliff, while the heroine Catherine is torn between her wild heart and the quiet respectability of the civilised world. The word heathen comes from the Old English heathen of Germanic origin, from the base of heath, and is generally regarded as a specifically Christian use of a Germanic adjective meaning inhabiting open country, and referring to a person who does not belong to the Christian religion. The only true natural types of heathland are montane, maritime and bog heath. Montane heath is found at high altitudes above about 700 metres, where exposure prevents the development of taller shrubs or trees. And maritime heath is found on cliff tops, where strong salty sea winds keep the vegetation low. The rest is semi-natural habitat, requiring human intervention to stop them developing into woodland. Much of the heathland in the UK was created back in the Bronze and Iron Ages by clearing forest so it could be grazed, used as bedding for animals, and the peat used for fuel. Nowadays, much of it is managed. There are cycles of burning, which is used to stop it returning to forest and to regenerate the heather. The fire prevents the heather becoming leggy and woody, and the new growth is fodder for grazing birds, like the red grouse in Scotland. And other grazing animals, for example sheep, deer, hares. In the UK, the environments where heather communities are ecologically stable and wouldn't be succeeded by woodland are challenging with strong winds and cold, wet weather, so it's unlikely that honeybees would survive in many of them, especially further north. Mostly you see the sturdier bumblebee, Bombus jonellus, here. Bees are brought into the heathland and moors when the heather is in flower and are removed afterwards. And it's questionable as to whether there would be sufficient forage for the rest of the year in such areas. They could perhaps have lived close by in wooded areas, but it seems that often man plays an intermediary role between honeybees and a crop they're so fond of. By contrast, in the Landes region of France, a maritime region, honeybees not only exist, but have developed an ecotype to coexist with this particular heath landscape. Their yearly cycle of brood rearing has evolved to coincide with the availability of their heather forage. Heathers like the air moist and for there to be plenty of light. The whole Ericaceae family prefer an infertile, acidic soil. They're able to live in a wide variety of conditions thanks to their symbiotic relationship with mycorrhiza. All three heathers have rootlets, extremely fine roots that are penetrated by the mycorrhiza, making it almost impossible to separate the rootlets from the soil. The mycorrhiza help the plants obtain nutrients where very little sustenance is available. The plants have a spreading tendency. Their lower branches are able to put out roots where they touch the soil, and it can be difficult to define where one plant stops and another starts. All heathers have a characteristic springiness, bouncing back after being trodden on. In the northern hemisphere, there are relatively few heather species, around 20, but they cover large amounts of ground. In contrast, in the southern hemisphere, specifically southern Africa, there are more than 600 species, but each only covers a small area. There is a huge variety of forms and colours, as you can see. In the areas I studied, in fact in most of Britain, my three heathers are the predominant species. And they also dominate northern European heathland, with a few additional species. Moving south towards the Mediterranean and a warmer climate, more species occur, but the forms and colours don't have the range of the Cape heaths. Ericaceae lives in wet, boggy soil conditions. The colour can vary from white through the palest pink to a darker pink that gets stronger when the ground is drier. Even in flower, it disappears into the landscape, virtually invisible. Each New Year's growth is not branched and gives a snake-like impression, as if uncoiling with a head angled horizontally. The young stems have white, non-glandular hairs. Leaves are evergreen and needle-like. They are grey and covered in glandular hairs, particularly at the edges. These have a glassy appearance. There is also a shiny orange bulbous base to each leaf where it attaches to the stem. Each leaf is identical, no metamorphosis can be seen. They have 4 hairy sepals. The corolla has bilateral symmetry, with 4 petals which are fused to create the characteristic bell shape, which opens only at the top of the flower. The pale pink flowers appear in a whorl at the top of the stem and hang down to face the earth. They have a superior ovary, and there are 8 stamens which are not attached to the corolla. The anthers have awns, or a bicorn, a forked tail at the base. After pollination, the flowers become brown and dry, and then turn up to face the sun. And here is a thrips. It's about 1 millimetre long and spends part of its life cycle in Ericaceae's flower. The small winged thrips are all females. The males are very rare and are wingless, so they're far more stationary than the females, which have to hunt for the males. This discovery, plus the observation that the Ericaceae's flowers reminded me of a polyp shape, an animal rather than a plant form, got me thinking about carnivorous plants. Nowadays, Ericaceae is considered proto-carnivorous, which means it doesn't digest the insects itself. It has no digestive enzymes, but can use the frass, excreta, for nutrients. So the carnivorous adaptation is the sticky hairs which trap insects rather than the flower which provides shelter, a home. Sundews grow side by side with Ericaceae in the New Forest. They're true carnivores with enzymes that enable them to digest insects. Although there are many similarities between Ericaceae and Ericaceae, their preferred soil conditions are quite different. Ericaceae likes a dry, sandy soil and can even be seen living directly on rock. The leaves are evergreen and needle-like and vary between light and dark green and have few small hairs. They circle the stem in whorls of 3. Like Ericaceae, the leaves have a bulbous base, although here it's less pronounced. The corolla has the same 4 fused petals, a striking magenta in this case. They can appear further down the stem. The anthers have no bicorn. Again, like Ericaceae, the flowers become brown and papery after pollination and then turn upwards. They can still be present on the plant the following year and can take this mummified form. Calluna is at home in soil conditions of both Ericaceae and Ericaceae. Leaves are evergreen, but here they're scale-like. There's no leaf stalk, and they attach directly to the stem. They have 2 leaves per node and no hairs. Each leaf has a pair of stipule-like lobes at the base. There's no obvious metamorphosis except perhaps a slight pointing. At the base of the flower are short stubby bracts. And there can be small hairy scales along the stem, which can also appear at the base of the inflorescence. The flowers open fully and are not fused, unlike other ericas. Petals alternate with the sepals and are more delicate than them. They flower all the way up the stem, the first flowers opening from the bottom up. Anthers have a white spur at the base. After pollination, the calyx and corolla close in again, leaving the pistil hanging out. It's then possible to see the rhythmic nature of the flowers along the stem. All 3 heathers show great resistance to decay. The leaves, needles or scales are evergreen. The flowers can stay on the plant for months, sometimes still present when the following year's flowers are there. They contain a high proportion of tannins, and historically the plants were used in the tanning process. This is a well-preserved Irish Iron Age bog body found in June 2003. The first of the heathers to flower is Ericaceae from June to August, followed by Ericaceae, which begins in July, and finally Calluna from August to late September. This covers their main flowering time, but they all overlap, and you will see stragglers continuing boldly past their documented times. Other members of the family flower at different times of the year, notably Erica carnea in winter. Hybridisation has meant that there could be one or other type of heather in flower all year round, i.e. the growth doesn't depend on the increasing power of the sun. In 1997, a German plant breeder, Kurt Kramer, developed a form of Calluna where the flowers never fully open. Known as the Garden Girls, these heathers have been a commercial success because the flowers, not being pollinated, remain in a permanently youthful state. Indeed, they're known as bud bloomers. They remain colourful throughout the winter, and although this has been a success for Kramer, unfortunately it's been less good for the bees, as the Garden Girls offer no bee food. This development highlights the family's ability to hold back. Calluna is bred horticulturally for coloured foliage too, which can be silver, green, yellow, red or even a blackish green. Here we see a feature of the flowering impulse coming further into the plant. The first stage of Goethean science is exact observation, using the senses to carefully examine the phenomenon, here the plant, at each stage of growth. Whilst we can only ever see a snapshot image of the growing plant at any one time, with our imagination we can put together the different stages of the life cycle, growing the plant in our mind's eye. This is the second stage, exact sensorial imagination. The plant's very livingness is thus included in the study. At this stage, relationships are also looked at, for example, to other members of the species, the family, to other plant families, and to the surroundings. Here sequences are sought, for instance the leaves from bottom to top of the flowering stem. One comparison that can be made is between the plant you're studying and an archetypal plant. Goethe was always looking for the Urpflanze, an ideal or archetypal plant. There are certain gestures typical of each stage. Roots. A radial character, branching and division. Earthy woodiness, and a tendency to become hard with age, although the tips always remain young and active. Stem. Vertical, between earth and sun. Leaves. Planar, spreading horizontally, substance production. Spiralling up the stem. Contraction into calyx, where the movement upwards is halted. Flower. Light, colour and scent. Refined substance. Opening. Fruit. Waiting, receiving, protecting. Closed off, creating an inside and outside. Spherical, expanding. Seeds. Independence from the mother plant, hard, dry contraction. So if we imagine an archetypal plant, we can gauge where our plant is different and so look to these features to help understand it. The leaves are weatherproof, are simple and lack metamorphosis. There's contraction rather than expansion here, as if their form is compressed. The way the leaves are arranged around the stem differs between the three species. Calluna having 2 scales per node, Ericaceae having 3 nodes in a whorl, Ericatetralix having 4 also in a whorl. There is none of the spiralling upwards typical of leaves' progression along the stem. The whorl is suggestive of the calyx of the archetypal plant, where the leaves become thinner and smaller, there is no metamorphosis, and they no longer spiral up the stem. This could suggest a flowering impulse entering deeper into the plant, into the leaf region. The regularity of the whorls and repetition, plus the specific number at each node, exhibits a rhythm, so an interpenetration of flowering and rhythmic gestures are at work here. Although these small shrubs do resemble trees with their woody trunk and branching into the surrounding space, their place on the earth is quite different. They spread out, covering the ground and never reaching up beyond a metre or so. Ericatetralix flowers only at the top of the stem. Ericaceae flowers mainly at the top, but also from side shoots, and Calluna flowers all the way up the stem. Thus, flowering penetrates deeper into Calluna than the other 2 Ericas. There's also a difference in the uprightness. Ericatetralix stoops at the top, and at the other end of the spectrum, Calluna is like a small steeple, quite upright. But the main difference is that the Ericas have the typical urn-shaped flowers, almost closed bowls which face down, whereas Calluna has open flowers facing outwards, horizontally. And here the closed-off nature of the Ericas is missing, and Calluna interacts with the outside space. Calluna shows more movement than the Ericas too, in opening fully and closing after flowering. Some of the South African Ericas are more tubular and show less of the rounded tendency, but Erica tetralix and Erica cinerea are both like little bladders with only a small opening at the top of the flower. This enclosure of air is an animal gesture, as if gastrulation's taking place, creating a dark internal space. It only applies to the Ericas, not Calluna, which is a species on its own in this family. The way the Erica flowers in closed space is suggestive more of the ovary than the archetypal opening to the heavens flower gesture. The characteristic Erica flower could be said to show a fruit gesture. This is a safe, protected space, which brings to mind the shelter provided for thrips by Erica tetralix's flower. The archetypal seed quality is evident in the heathers too. This is something that fits the plant more as a whole and is supported by the plant's resistance to decay, their slow growth, lack of change, like suspended animation. The Ericaceae could be said to show a Saturn influence. Saturn, as the former outermost planet of our solar system, can be seen as the container for other planetary influences. The far planets, Mars, Jupiter and Saturn, take the seed plants, angiosperms, beyond life processes and into independence. Warmth permeates life processes leading to ripening of the fruit and withering and drying out. The seeds that develop inside the fruit contain hardly any moisture and have dry, hard seed coats. It's as if, from above, everything is pushed deeper into the plant. Above ground, everything shrinks away from the environment into itself. Whereas below ground, the opposite happens. The roots spread out near the surface and open themselves to the elements. Branches can take root where they touch the ground. There's a polarity between the top of the plant and the bottom, the roots. The strong life force can be observed contained inside the plant, evident through its springiness. Yet they're self-sufficient. There's a feeling of self-reliance, self-preservation and self-possession, that they can wait for better conditions, ride the storm. Their self-protection, like a seed, does seem to be a fundamental quality of the heathers in the way they hunker down and contract away from the hostile environment, expressed so well in the urn-shaped Erica flowers, and in the contracted needle-like leaf. And the heathers have got a close relationship with warmth. The dead wood is good tinder, being brittle and flammable. The plants also regenerate well after fire, hence the controlled burning used to manage the heath and moors in order to provide fresh new growth for grazing. Underlying peat soil, made partially from decayed plant material, including sphagnum moss and many other plant species like heather, is also flammable and, if insufficiently wet, can slow burn for years. Also suggesting inner warmth is the plant's ability to survive such harsh weather conditions in such an exposed environment. The warmth appears to be reflected in the honey. Whilst the nectar appears clear and has little viscosity, the honey has a rich amber colour. The dark colour means it has more minerals in it, showing a physicality in the warmth. Calluna's honey is particularly viscous and has a rare quality, thixotropy, meaning it appears as a gel or solid until moved or agitated, when it becomes liquid. To help clarify, the opposite quality, sheer thickening, can be seen in a semi-liquid cornflour and water mixture. Here, when stress is applied to the liquid, it becomes hard. The heather honey combs can't be spun, but must be pressed to extract the honey. It's said that if very pure, unadulterated by other plant nectar, it may not crystallise at all. Crystallisation is a hardening, becoming earthly, and to not crystallise is an indication of not just longevity, but something eternal. A very few honeys have a similar thixotropic quality, notably grapefruit, Abies species and Manuka. Calluna and Manuka have been well researched, and out of all honey-producing plants are particularly valued for their exceptional antibacterial and antimicrobial properties. The moor and heathlands can feel very different at different times of year and in different locations. Perhaps the essence of where heather grows is its openness to the heavens and to light, and the feeling of space. Its spreading habit, along with this openness, appear as a polarity to the plant's detachment and contraction in its form, away from the outside space. Lying on the heath, one feels a sense of openness, an opening of the chest area, and support from below. I spent an afternoon in Yorkshire lying on the moor. It was an overcast day, but with closed eyes there was such a strong sense of light, I had to several times open my eyes to check whether the sun had come out or not. It hadn't. In opposition, however, is the separation of the heath and moorland from the cultivated or so-called civilised world, the poor acidic soil where no food can be cultivated, and the heathen as outcast from a religious society. Rudolf Steiner talks of the heathens as being still in touch with the spiritual world, seeing spirit in all nature. When Christianity spread, those who didn't change were excluded. The moor and heathland are somewhere to go to escape society, isolated spaces where, paradoxically, man can renew his ability to feel connected. At the heart of heathers is this polarity between contracted, condensed form and open, light landscape. They are a community, individually so small as to be hard to see without a magnifying glass, but together carpeting entire mountainsides in purple. The gesture of heathers doesn't go as far as the independence Cranach talks of. Because they're a community, not isolated from each other, but working together. Heathers are quite difficult to read. The leaves have no real metamorphosis, and the plants grow very slowly, making their study a lengthy process. In order to gain a comparison, I'd selected two plants from the Boraginaceae. Borage is a good honeybee plant and an annual, and allowed me to observe the growth patterns more easily. The other member of the family I chose was comfrey, not a honeybee plant, but popular with other bees and a known healing plant. Borage comes from North Africa and the Mediterranean and enjoys light sandy soils. It grows up to 1 metre tall. The whole plant glows with the light of the silica hairs. The roots are quite small and can be very easily pulled up. They live without any mycorrhiza. Borage begins its season's growth with fleshy cotyledons. The leaves are alternate and form a tightly packed rosette to start with. The stems are mucilaginous. They're fleshy, branched, ridged and hollow with silica hairs. Side shoots develop soon after the stem starts to sprout upwards. On the flowering stems, the leaves become smaller and start to become pointed at the tip, and finally the petiole disappears. The leaves spiral around the stem at an angle of 144 degrees, so it takes 2 cycles to return to the starting point, and 5 leaves. The calyx has 5 hairy sepals which alternate between the petals. The buds begin to show at a very early stage, before the stem has started to elongate. At that stage they point upwards. Just before flowering, they hang down towards the earth and open with the flower. Buds emerge pink and when the petals unfold turn blue. The petals and sepals turn from pink to blue because the acidity of the cell sap changes from acid to alkaline as it loses its vitality with age. White scales stand in the throat of the corolla and staminal appendages also turn from red-pink to blue. There are typically 5 stamens that are attached to the corolla. As the flower ages, the petals recurve. Each flower lasts about a day before the fused corolla and stamens fall to the ground. There's a rhythm to the unfurling of each cluster. The first to open is the inwardmost bud. It rises above the future buds on its peduncle or flower stalk. The flower stalk then falls again as the next bud from the outside starts to rise and open. The calyx then closes. It becomes clear later that flowering has alternated from left to right along the flower stem. The main stem begins upright, but loses its ability to maintain an upright position and flops to the side. They have continued to grow between flowering and releasing the seed, and remain open after the seed has fallen. It's bilocular, each locule being divided by a false septa into 2 parts, so forming a 4-parted ovary, each containing 1 brownish-black nutlet. Borage oil extracted from the seeds has a high gamma-linoleic acid content. It's the main source of GLA along with evening primrose oil, and here we see evidence of the warmth element in the seed. Pelican makes some important observations about nectar from this family. He talks of an impulse passed from plants to bees via their nectar, warmth in the case of Labiaceae, and silica processes in borage. What might be the impulse passed along by the heathers, particularly Calluna, such a favourite of honeybees? Symphytum likes water meadows, damp places, roadsides and waste ground. It's a perennial found in Europe and West Asia. It grows up to 1 metre tall. The root is a deep taproot. It's dark brown on the outside with a fleshy white inside, which is slimy, mucilaginous to the touch. The inside soon turns brown on exposure to air. The main constituents are mucilage, allantoin, pyrrolizidine alkaloids, saponins and a little tannin. The more toxic pyrrolizidine alkaloids are not found in Symphytum officinale. Allantoin is a cell proliferant and helps wounds, burns and ulcers to heal. It's named after the allantois, found as an embryonic excretory organ in animals. After birth, it's how nitrogenous waste is excreted in animals. In humans and other higher animals, the metabolic pathway for conversion of uric acid to allantoin is not present, so uric acid is excreted. Comfrey's common name, knitbone, reveals its ability to help set broken bones and fractures. I did attempt this. And two pieces did stick together. A bit. Like borage, it has fleshy, hollow stems covered with silica hairs. In a plant with such an affinity for the water element, a hollow stem is a surprise. This indicates the air element has penetrated deeply into Symphytum. The stems are ridged and show a tendency towards merging with the leaves. Comfrey's undivided leaves form a loose rosette at the start of the season. Comfrey makes a good feed for plants, being rich in nitrogen and potassium. It's a good compost activator because it has a low carbon to nitrogen ratio and breaks down quickly. The deep taproot mines minerals from the earth. Symphytum doesn't glow with light like borage, the hairs are more modest. The plant has more of a base, a strong root and much leaf growth at the base before the stem reaches up. It too will topple over, but it doesn't rock the whole plant as with borage. The curving of the borage petals is suggestive of wings. It's as if a 5-winged bird was taking off. Symphytum shows a similar gesture, but in the topmost leaves rather than the petals. This 2-winged gesture feels animal, bird-like, the wings up and the head down in Comfrey. In both the movement is one of lifting off rather than gliding or flying. The calyx has 5 hairy sepals which are fused. The flower cluster is a scorpioid cyme that curls under, from which the tip at the centre of the coil is last to flower. Unlike borage, the flower buds don't appear until the main stem has risen. Like other Boraginaceae, there is a change of colour between bud and flower, and they can fade from a dark, intense colour to paler, washed-out colour. The stripes on Symphytum officinale in the petal are a variation on this theme. The colour changes show that the water element is active in the flowering region, usually the domain of light and air. There are typically 5 stamens that are attached to the corolla, alternating with throat scales. The corolla quickly turns brown and falls to the ground, revealing the long white pistils. They have a superior ovary, and like borage, the fruit is a schizocarp with the 4 one-seeded brownish black nutlets. Comfrey renews vegetative growth after flowering with even larger leaves. And sometimes it flowers again, breaking down, building up, breaking down, building up, breaking down, building up, breaking down, building up, breaking down, building up. Symphytum has great affinity with the water element. The root is succulent and mucilaginous. The flower changes colour, but more as if diluted than the pink to blue typical of the Boraginaceae, related to acidity. The leaf is planar and entire. The whole plant is plastic and continually in movement, reminding one of a mushroom vortex. It's a master at creating substance and shows itself to have a strong life force, not just in a positive sense, but also in its ability to decay quickly, an indication that the air element has penetrated deeply into it, and it has a strong vegetative ability to regenerate. Borage shows movement in several respects. The raising of the flower stalk when it's flowering, followed by a retreat to below the stem. The petals recurve and twist. The flowering stem late in the season when the seeds have been released and the whole plant leans over. It strives for uprightness, but despite the presence of silica in the plant, unlike horsetail or a grass, it can't maintain it. Almost like a wave rearing up before coming crashing down to earth. It brings to mind the tomato plant with its similar flowers and inability to be upright. Borage and comfrey also face down to earth. It's as if they only briefly touch the higher realms before turning back to earth to produce and release their seed. In contrast, the Ericas show little movement and are much slower. There's little metamorphosis in the leaves, and where the Boraginaceae remain facing the earth during seed production, the Ericas turn upwards, although Calluna does stay facing horizontally and has shown more movement with its opening flower. The lively Boraginaceae calyxes are missing in the Ericaceae as they remained open around the long-lasting flower. This permanence contrasts with borage, whose flower falls within 24 hours, but even more so with comfrey, where the flower's already brown before it falls. Comfrey is busy regenerating itself, while the heathers just stay as they were. Comfrey's catabolism and anabolism show its activity in the metabolic realm. In the introduction, I said what I'd hoped to do was understand the plant's qualities at a deeper level, in order to be able to understand better the effects of a particular honey on bee well-being and to have a better idea of how to investigate further. So has this study of heathers helped discover more about a quality or qualities the plants might pass on to the bees? This study has shown a relationship between the ability to resist decay in heathers and the ability of bees to overwinter successfully. The resilience of heather in a hostile environment may echo the colony's attempt to seal itself off from the outside through the winter and maintain its warmth. The warm dark hive interior matches the Saturn seed gesture. Equally, the heather's seed gesture brings to mind the overwinter clustering, a contraction opposite to the expansion of midsummer when the bees extend the hive's reach by a few miles. The summer expansion is much more closely related to the borage gesture. The contrast between the individual heather plants' held back nature and their expression on the landscape is stark. The inward-looking, protective and closed nature of heather is polar opposite to their spreading habit, covering huge areas and growing no more than 1/2 metre high, an open, airy, light gesture. There's also the polarity between southern and northern hemispheres, many species each covering only a small area in the south, and few species covering large areas in the north. In Europe they make up a community, each small plant merging with its neighbours and carpeting the land, whereas in southern Africa they're more individual. Could there be a relationship here between the bees as individuals and as a social organism? The difference between Erica's and Calluna's open flower form is intriguing. The seed gesture is most strongly shown in the Erica flowers, yet Calluna shares the qualities of permanence and being held back. If the fruit and seed gesture qualities are pushed more deeply into the Ericas, is Calluna less affected? The feeling I have is that Calluna manages to resist an inward pressure and to turn around to shine its light back out into the heathen landscape. Another question is whether honeybees would naturally have Calluna and Ericaceae as their diet. In the more extreme environments where heather would not need to be managed to exist, it's more likely that hardy bees such as Bombus journellus and the tiny thrips would be the main pollinators. It's curious that a plant reputed to help bees overwinter is not naturally available to them in many instances. They do seem to have developed a particular relationship with man. The issue of man intervening to ensure a habitat can exist is very topical. Wilding is being experimented with, and we're learning a lot about what happens when nature's left to her own devices. This study has given me pause for thought about this practice. Not that it isn't a good thing to do, as we learn so much about how nature rebalances, but that it may not be the only path to a good relationship with nature. Once we understand more deeply, we'll be able to become more consciously involved. Perhaps wilding is more like going back to the heathen way, back in touch, but not yet with conscious awareness. Calluna, with its scent of honey, seems to produce an almost archetypal honey of deep, warm colours and suspension from life and death in its not crystallising. Borage gives a very different picture. The whole plant is suffused with light and shows an affinity with the sun. As an annual, it develops with the increasing sun and fades along with it. In the bee's annual cycle, this corresponds to a build-up of brood, peaking at the summer solstice, before declining numbers into the late summer and autumn. One can see why borage is such a favourite with bees. There's a feeling of the plant and life cycle of the bees being in tune. It may seem like common sense that plants offer the right food for bees and other insects at the right time of year, but by getting to know the plants more deeply, the relationship has become a little clearer. Older studies that equated nectar with carbohydrate for fuel and concluded that was therefore no difference between feeding candy or honey to their bees. miss a more qualitative understanding. There are subtle qualities that may not be measurable in terms of their effect on bee health, but by becoming more aware of the connection between the plant, the bee and the planetary rhythms, maybe we can gain a deeper understanding of why diversity is important. There may well be more questions arising from my study than I have answered. But I've learnt so much from my journey with the heathers, Borage and Comfrey, and with Goethean science.